I am Madam Rosmaya from SMJK Yuhua. So the topic that we are going to discuss today is wave intensity. So we are going to discuss the wave intensity from the two type of source. Okay, the first one is from point source, and another one is from the linear source. So the symbol for wave intensity is I. Okay, if the source of the wave is from a point source, and let's say the source emits energy at rate P. So P is power, A is area, and I is intensity, and R is radius. So from the formula, intensity equals to power per area. So the area from a distance R is the area of a spherical, which is the formula is 4 pi r squared. And P is a constant because it comes from the source, okay, a source. So the power of the source is constant, and then 4 is a numerical value, also constant. Pi also a constant value, so therefore the intensity is directly proportional to 1 per r squared. Okay, this means that this wave intensity from a point source follow the inverse square law. Okay, so the unit for intensity is watt per meter squared. Okay, just as with the oscillation that starts it, the energy transported by a wave is proportional to the square of the amplitude. So in the mathematical form, we write intensity is directly proportional to the amplitude squared. This comes from the I, okay, intensity equals to power per area. So that means I is directly proportional to power. And from the previous lesson, okay, power is directly proportional to the energy. So therefore, energy is directly proportional to the amplitude squared. Okay. And we combine with the previous slide where we get intensity is directly proportional to 1 per r squared. And combine these both, we get amplitude squared is directly proportional to 1 per r squared. And we squaring both sides, so we get amplitude directly proportional to 1 per r. So this is the formula which relates amplitude and r, right? Distance from the point source. Okay, from the previous lesson, total energy from the wave we got half m omega squared amplitude squared. So the total energy is directly proportional to the amplitude squared. Okay, now what if the energy radiated from the linear source? Okay, the linear source, example this one. So from distance, let's say r, from the source, the shape is a cylindrical shape. Okay, so from the formula, intensity equals to power per area. So the area now is the area of the cylindrical shape, which is 2 pi r per L. 2 pi r L. Okay, 2 pi r, the circumference of the cylindrical here, top here, circle, and the L is the height of the cylindrical shape here, 2 pi RL. And from here, this means that the intensity from linear source is not a inverse square law, is directly proportional to 1 per R only. Okay, so now we are going to relate with the amplitude squared. So intensity is directly proportional to amplitude squared. We combine with the I intensity directly proportional to 1 per R. So combine these both, we get amplitude squared directly proportional to 1 per R. And squaring both sides, we get amplitude directly proportional to 1 per cert r. Okay, so remember this formula for today's topic. Okay, if the point source is a if the source is a point, so intensity is directly proportional to 1 per r squared. But if the source is a linear, so intensity is directly proportional to 1 per r. And for both, intensity is directly proportional to the amplitude squared. Okay, so now we try one example. A circular wave is produced on the surface of the water in a ripple tank. The intensity at a distance of 5.0 cm from the source is 1.0 watt per meter squared, and the amplitude at this point is 0.5 cm. So what is the intensity? B, the amplitude of the wave at a distance of 20.0 cm from the source. So we try question A first. The circular wave is produced on the surface of the water, okay, in a ripple tank. So that's mean it is like the second point source, which is linear source. It's not surround the source here, but it's only on the surface. So therefore, the source of the wave will form at distance r is a cylindrical surface. So therefore, we use intensity directly proportional 1 per r. So we go back to the equation just now. So the point, the source is linear, like this. So we choose this formula. Intensity is directly proportional to 1 per r. Okay, from this formula, okay, we form the equation I1 per I2 equals to R2 per R1, because this is inversely proportional. Okay, so now we substitute the values given. So I1 is 1 watt per meter squared. I2 is what we are going to find, okay, at a distance R. So the distance is 20 centimeter. I2, so the distance R2 is 20 centimeter. And the initial distance is for 1 watt per meter squared is 5 centimeter. Okay, so now we cross multiply, we get I2 is 0.25 watt per meter squared. So this is the answer. Okay, next we find the amplitude of the wave at a distance 20 centimeter from the source. So for amplitude, we use the formula. Intensity is directly proportional to the amplitude squared. Okay, but this time is also directly proportional to 1 per r. So therefore, squaring both sides, we get amplitude directly proportional to 1 per cert r. Okay, now we form two equations because this is inverse. So A1 per A2 equals to cert R2 per cert R1. Because this is inverse. Okay, so we substitute the two situations. For first situation, A1 is 0.5 centimeter, the amplitude, okay, at this point, 0.5 centimeter. So amplitude A2 is what we are going to find. And the distance for R2 is 20 centimeter. And for initial distance just now with 1 watt per meter squared, or amplitude 0.5 centimeter squared, the distance is 5 centimeter. Okay, so now we solve for A2, we get 0.25 centimeter. So this is the answer for the amplitude. Okay, I hope that you all understand. And that's all for this video. And thank you for watching.